Okay, in this video we are going to be looking at question 14 from the WJC additional maths paper from June 2015. So the question says we need to find the coordinates and the nature of each of the stationary points on the curve y equals 2x cubed minus 24x plus 13, showing all our working. So as soon as I see stationary points, I like to start with my y, which is 2x cubed, minus 24x, plus 13. Then I like to find my first derivative, so dy by dx. Okay, so 2x cubed will differentiate to two lots of the derivative of x cubed, so 3x squared. So that's 6x squared. Minus 24x will differentiate to minus 24, and the plus 13 will disappear. I'm also going to find my second derivative, so d2y by dx squared. And my negative 24 will disappear. So I'll just box these off for when I need them. Okay, so that's all the information I need. So the first thing that I do, once I've done all of this, I make my initial statement is that we have stationary when dy by dx is 0. Okay, so that implies then that 6x squared minus 24 is 0. Now I can divide everything here by 6. So you get x squared minus 4 is 0. Now there's two ways to solve this. We can either add 4 and then square root. Or, if you notice, this is a difference of two squares. This is x squared, which is obviously a square, and 4, which is 2 squared. So we can factorize this like a difference of 2 squared. So x plus 2, x minus 2 equals 0. By doing it this way, you're far less likely to forget that there are two possible solutions here. So we either end up with this first bracket, x plus 2 is 0, so you'd have 0 times something, which is always 0. Or we end up with the second bracket, x minus 2 is 0, so we end up with something times 0, which again will be 0. So this gives us two possible x values. X is negative 2, or x is 2. Now, that's the x-ordinate of our two stationary points. We need the coordinates, so we need both ordinates. So we need to substitute into y to find that value. So let's have a look. When x equals negative 2, y is going to be 2 lots of negative 2 cubed minus 24 lots of negative 2 plus 13. Plug that into my calculator. So I've got 2 lots of negative 2 cubed minus 24 lots of negative 2 plus 13 is 45. Just double check I've typed everything into my calculator correctly. Okay, I have. So that gives me the point negative 2, 45. And when x equals 2, doing the same substitution, but putting in 2 instead of negative 2. Gives me, so I can just change the negative to positive in my calculator, negative 19. So I can then say that therefore I have two stationary points. And they are negative 2, 45, and 2, negative 19. So that's the first part done. I've found the coordinates of them. Now I need to find the nature of them. So whether they're a maximum or a minimum. Now, I can use logic to do this because this is a positive cubic. And a positive cubic will look something like this if I got 2 stationary points. So the one that's furthest to the left, which is going to be this one, that's going to be a maximum. And this one is going to be a minimum. So we know what our answer is going to be just by thinking about it a little bit. But let's prove it mathematically beyond a reason, any doubt at all. And the way that we do that is by looking at the second derivative. So I'm going to find the nature. So if I look at the first one, negative 245, then my second derivative, d2y by dx squared, which is 12x is the expression. So it's going to be 12 lots of negative 2, which is negative 24. Okay, this is negative or less than 0. Therefore, that means that the rate of the change of the gradient is negative, which means it's becoming more and more and more negative. So if it starts positive, as it becomes more and more negative, that means it's less and less positive until it gets to there, and then it becomes more and more negative. So we end up with a maximum. So therefore, this is a maximum point, which is what we expected. And if we take the other point, which was 2, negative 19, then the second derivative, d2y by dx squared, is going to be 12 lots of 2, which is 24, which is greater than 0. And if it's greater than 0, that means that the rate of change of gradient is a positive one. So that means the gradients become more and more positive, or less and less negative. So if it starts as a negative and becomes less and less and less negative, it means it becomes more and more and more positive. That becomes a minimum. So therefore, it's a minimum, which again is what we expected. And then that are the coordinates and the nature of the stationary points.